Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over how to multiply decimals by whole numbers. The types of problems we're going to be covering in this presentation are given here: 57.2 multiplied by 7 and 53 multiplied by 0.005. Don't forget, we have some practice problems at the end of this presentation that we'd like you to try out in order to demonstrate mastery of the contents of this tutorial. Alright, so the instructions are for us to find the products of the given numbers. So let's write that down. So we're to find the product. For question number 1, what if we're multiplying the decimal 8.7 by the whole number 3? How do we carry out this multiplication? Now, when you're multiplying decimals by whole numbers, what you do is you follow the same procedure as you do with regular multiplication of multi-digit numbers. You ignore the decimal first and then use the number of digits to the right of the decimal in both numbers to determine where to place your decimal point. Okay, so in this case, our multiplier is the only decimal, so that's the only number that will determine where we're going to place our decimal point. Okay, so let's go ahead and ignore this decimal point for now, act as though it's not there. We're going to apply the skill we covered in, I believe, is unit 2, how to multiply 2 digits by 1 digit here, and then we're going to talk about how to place the decimal point. Alright, so we're going to take the 3 and multiply by both numbers. 3 times 7 is 21. Place the product digit underneath the place value of your multiplicand. Okay, remember that. It's multi-digit product, so you put a 1 down, carry the 2. 8 times 3 is 24. 24 plus 2 is 26. So we have 261. Alright? If there were no decimal points there, our product would be 261. But since there's a decimal point there, our answer will not be 261. Okay, so how do we place the decimal point of the product? Now what you do is you look at how many digits are to the right of the decimal point. Non-zero digit. How many digits are to the right of the decimal point? So in this particular case, we have exactly 1 digit. Okay, 1 digit to the right of the decimal. Okay, all right, so since you have 1 digit to the right of the decimal, then we're going to place our decimal point 1 place to the right, to the left. So it's going to start from here and we're going to move it right here. Bam. So our product is going to be 26.1. That's the answer. Okay. Or another way you can look at it is you ask yourself, how many times do I have to move the decimal points in order to get rid of the decimal points in the factors, the multiplier and the multiplicand? So look at 8.7. How many times do I have to move the decimal point to get rid of the decimal point here? You move it only 1 place to the right, right? So you do the opposite with the product. You move it 1 place to the left. You get 26.1. All right, let's take a look at another example. Question number 2. What if we have the product of the decimal 0.73 and the whole number 9? Okay, just looking at this product, the product of these two numbers, can you determine where the decimal point will be? You notice that there are 2 digits to the right of the decimal, or you have to move your decimal points 2 places to the right to eliminate the decimal point. So our decimal place will be 2 places to the left of our product. Okay. All right. So let's go ahead and multiply first. Ignore the decimal point. Okay. 9 times 3 is 27. Put a 7 underneath the 9, and then you carry it over 2. 9 times 7 is 63. We carried over 2, so 63 plus 2 is 65. So 657 if none of our factors were decimals, right? But our multiplier is a decimal, so we have to apply a decimal point. So remember the rule: how many digits to the right of the decimal? Okay, here there are 2 digits, or you have to move your decimal point 2 places to the right in order to get rid of the decimal point. So you have 2 digits to the right of the decimal point. Okay, so here what we're going to do is we're going to start from the rightmost position and then move our decimal point 2 places in the opposite direction. 1, 2, bam, there goes your decimal point. So our product is going to be 6.57. Okay, all right, let's go ahead and try another example. Now what if we were to multiply for number 3, 75.3, and the product of 75.3 and a whole number 8. Okay, we're going to follow the same procedure here. Assume that there is no decimal point. Just multiply first, and then we're going to move our decimal point 1 place to the left because there's only 1 digit to the right of the decimal point. Okay, all right, so 8 times 3 is 24. Put down a 4, carry 2. 8 times 5 is 40, plus 2 is 42. So put down the 2, carry over 4. And then 8 times 7 is 56, plus 4 is 60. Okay, so the answer would have been 6,024 if there were no decimal points. But we have a decimal. Our multiplier has 1 digit to the right of the decimal point. So what does that do to our product? It moves the decimal point 1 digit in the opposite direction. Okay, so here we have 1 digit right of the decimal point. So that's why we have to move the decimal point of the product 1 digit in the opposite direction. 602.4 is our answer. So let's write down the product. 602.4. Okay, let's go ahead and try another example. For question number 4, what if we have to find the product of 150 and 0.004? Okay, so let's orient it vertically. We're going to be multiplying vertically. We're using the stacked method for 0, 0 and the decimal point. Bam. Okay, so let's go ahead and multiply these two numbers. So we're going to multiply first, assume that there is no decimal point. Okay, all right, and then we'll deal with the placement of the decimal point after we find the product. So we're just going to multiply 150 by 4 since these are zeros, and when you multiply any number by 0, you just get 0. Okay, 4 times 0 is 0. 4 times 5 is 20. Put down 0, carry over the 2. 4 times 1 is 4, plus 2 is 6. Okay, if there are no decimal points, our answer will be 600, but there are decimal points here. Okay, so how many digits to the right of the decimal point? We have 1, 2, 3. 3 digits to the right of the decimal point, or you have to move the decimal point 3 places to the right in order to eliminate the decimal point from the factors. All right, so let's see here. We have 3 digits right of the decimal point. So what does that tell us? The placement of the decimal point in our product is going to be 3 digits in the opposite direction. So we're going to go 1, 2, Bam, right there is the placement of the decimal point for your product. Our final answer, ladies and gentlemen, is 0.6. Okay, there you have it. All right, let's take a look at one more example and then we'll give you some practice problems to try out. Okay, so for question number 5, we're going to be looking at a word problem, a story problem involving calling cards. So consider the following situation, number 5. An international call calling card charges 56 cents per minute for calls to, let's say, calls to Jalisco, Mexico. Okay. So this is the question. James makes a call for 150 minutes. All right. So James makes a call for 150 minutes. Question is, how much does the call cost him? All right, how much are we taking out of his calling card? All right, so let's go ahead and solve this problem. Now, to get us started with this one, we are going to specify the formula that will guide our problem solving process. Okay, so for a problem like this, we have a unit cost and multiple units of that particular unit cost, and we want to find the total. We're going to use the following formula. The total cost is basically the unit cost, the cost for each item, in this case each minute, right, multiplied by the number of units. How many minutes did you call? All right, so that's the formula that we're going to be using. Now let's adapt this formula to this particular problem. The total cost for what's his name, James, is going to be the unit cost, which is cost per minute. How much does it cost per minute to make the call? And they'll multiply that by the number of units, which is the number of minutes. How long did he call for? Alrighty. So cost per minute, CPM, is 56 cents. So if we want to write it in terms of dollar, we can write this as 0.56. That was the cost per minute. The number of minutes is 150 minutes. So 56 cents times 150 will help us determine how much the call cost James. All right, so let's compute the product. We're going to be multiplying the whole number 150 by the decimal 0.56. Okay. All right, so following the same procedure, we're just going to multiply the numbers as though there wasn't a decimal point. And then consider the number of decimal digits to the right of the decimal, or how many times you have to move the decimal to the right to clear out the decimal points to determine the placement of the decimal point in our product. Okay? All right, let's multiply. We're going to be using our algorithm for multiplying 3 digits by 2 digits here. So first, 6 times 0, we're starting with the ones place. 6 times 0 is 0. 6 times 5 is 30. 0 carry 3. 6 times 1 is 6. Add that 3 is not, it's going to be 9. All right, now we're going to move to, if the decimal point were in here, this would be like the tens place, right? But with the decimal point is the tenths place. It doesn't really matter. We're just going to put the digit, the product, underneath the second position right here, okay? So ignoring the decimal point, it will be like the 10th place position. So to ensure the placement of our product digits are in the right position, we're going to insert a placeholder in the ones place right here. Bam. Okay, let's commence with our multiplication. 5 times 0 is 0. 5 times 5 is 25. So put down the 5 and carry over 2. And then 5 times 1 is 5 plus the 2 is 7. Okay, just ignore the decimal point for now and just multiply as you would a 3-digit by 2-digit. I'm going to go ahead and add downwards. 0, 0, 9 plus 5 is 14, 4 carry 1, and that's 8. Alright, so had there been no decimal point, it would be 8,400. But we have 2 digits to the right of the decimal points, namely 5 and 6. Or we have to move our decimal point 2 places to the right to eliminate the decimal point from all the factors of the product. Okay? All the factors that we're multiplying by. So we have, let's put a side note here. 2 digits are to the right of the decimal point. So how does that affect the product? Well, that means we're going to move the decimal point in the opposite direction by that same magnitude, namely 2. So move it 2 places to the right, to the left, sorry, 1, 2, and that's the placement of your decimal point. The product is 84. Okay? What does this answer mean in the context of this problem? Let's write down our conclusion. Our conclusion is as follows. The call costs James how much? The call costs James $84. That's a lot of money. Alright, so now it's your turn to do some practice problems. Alright, so what we'd like you to do at this time, go ahead and pause the video presentation, try out these 5 practice problems. When you're done, click on the playback button and we're going to reveal the correct answers for you to check your work. Alrighty, ladies and gentlemen, welcome back. Hopefully you had a time to try out the practice problems without a calculator, of course. Here are the answers. Go ahead and check your work. How well did you do with these 5 practice problems? Let us know in the comment section below how well you did. If you have any questions, just specify it in the comment section below, or you can ask your teacher for assistance. Thanks so much for taking the time to watch this presentation. Please help support our channel by liking, subscribing, and sharing with your friends. Tons of support resources can be found at our website at mathgotserved.com, or you can just take a look at the links in the description below. Thanks again for watching. We'll see you on the next one. Bye-bye.